countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Yang dihormati para guru, ibu bapa dan pelajar-pelajar sekalian, selamat datang ke Pusat Tuisyen AYU dengan usaha sama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Sebelum kita mulakan kelas, eloklah kiranya kita membaca umul kitab bagi yang Muslim dan bagi yang bukan Muslim berdoa menurut kefahaman masing-masing. Al-Fatihah. Apa kabar pelajar-pelajar sekalian? Harap semuanya berada dalam keadaan sihat dan bersedia untuk meneruskan kelas kita pada hari ini. Cikgu percaya para pelajar sudah tidak sabar untuk meneruskan kelas kita pada kali ini. Cikgu perkenalkan diri dahulu. Nama saya ialah Cikgu Shahnon dari Kolej Matrikulasi Pulau Pinang selaku moderator pada petang ini. Dan kelas kimia kita pada petang ini bertajuk Group 14 yang akan disampaikan oleh Teacher Vivi Lau. Teacher Vivi Lau ini mengajar di SMK Tinggi Kelang. Okay. Dan pada petang ini kita bersiaran secara langsung dari channel Teacher Vivi Lau. Kepada yang belum subscribe, silalah tekan butang subscribe sebagai tanda sokongan kepada beliau. Dan untuk makluman, Teacher Vivi Lau ini baru saja menerima suntikan pertama untuk vaksin. Masih cergas nampaknya. Bersama kita juga di atas konti ini ialah Teacher Tang dari Kolej Matrikulasi Selangor yang bertindak sebagai control host. Beliau dari Kolej Matrikulasi Selangor. Ya. Dan tidak dilupakan Teacher Kong dari Kolej Matrikulasi Perak yang berperanan sebagai pegawai pemerhati dan memang tidak disangkakan beliau juga baru menerima suntikan vaksin juga macam Teacher Vivi Lau. Okey, sebelum kita teruskan kelas kita, ingin cikgu ingatkan semua pelajar dan para penonton yang ingin menghantar komen supaya menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Cikgu percaya semua yang hadir pada petang ini merupakan pelajar-pelajar yang cemerlang dan mari kita tunjukkan disiplin yang terbaik. Sila fokus pada isi pelajaran yang akan disampaikan. InsyaAllah, moga kelas kita pada petang ini dapat dimanfaatkan sepenuhnya oleh para pelajar. Untuk makluman, link sijil akan diberikan di akhir siaran. Sila gunakan email e-didik sahaja. Sila ambil perhatian, link tersebut akan tamat tempohnya setengah jam selepas sesi live ini berakhir. Baiklah. Seterusnya, khas untuk para pelajar sekalian, cikgu akan umumkan passcode bagi kredit AYU. Passcode ini akan diumumkan sebanyak 3 kali ya. Di awal siaran, di pertengahan dan di pengakhiran siaran. Dan sekarang ini saya akan umumkan passcode di awal siaran. Okey, passcode bagi kredit AYU. Yang pertama ini ialah huruf A dan nombor kosong. Cikgu ulang. Huruf A ayam dan nombor kosong, ayam dan telur ayam. Jadi tanpa membuang masa lagi, mari kita saksikan Group 14 yang disampaikan oleh Teacher Vivi Lau. Dengan segala hormatnya dipersilakan.
Thank you very much, Cikgu Shannon, our moderator today. Thank you, Teacher Tang, as our control host. Thank you, Teacher Kong, as an observer today. Good afternoon, teachers and students. Today I'm going to teach about group 14. Okay, so first let me introduce myself. My name is Lau Chai Wee. I'm teaching in Pusat Tingkatan 6 SMK Tinggi Grang. My channel is Vivi Lau. Okay, here I want to introduce my PU teammate. So we have mathematics, which is led by teacher Im. Okay, we have mathematics T and M here, and we have biology. Okay, the ketua panitia is Cikgu Faizah. Then we have physics, Madam Rosmaya as a ketua panitia. We also have economy and perekonomian, which is led by Madam Fizi. And last but not least, we have chemistry, which is led by Cikgu Shannon. Okay, today we will going to learn about group 14. So these are the learning outcomes. So we will learn about physical properties and chemical properties. Okay, so first let's look at physical properties of group 14 elements. Okay, so the valence electronic configuration, the general valence electronic configuration we have. Okay, but first we look at the elements in group 14. We have carbon, silicon, germanium, tin, and lead. So to memorize, you can use this one, mnemonic, to help you memorize. But in the exam, you will have periodic table provided to you. Okay. So this is just convenience for you to remember the elements. So chemistry generates sandy problems. So we have carbon, silicon, germanium, tin, and lead. Okay. Okay, so this is a general valence electronic configuration. NS2 and P2 because group 14 has 4 valence electron. So if period 2 carbon is 2s2 to P2, so the N is period number. So for silicon is 4s2 4p2, and germanium 5s2 5p2, and so on. Okay, so group 14 is a group that show the clearest trend from non-metallic to metallic character with increasing atomic number. So carbon is non-metal. Okay, so silicon, germanium is metalloid. Tin and lead are metal. Okay, so you can see here. So the first physical properties you have to learn for SCPM is electrical conductivity. Okay, so because of the going down group 14, the metallic properties increase, become more metallic. Okay, so metals, you know, they have relocalized electron, so electrical conductivity will increase going down the group. So metalloid, they are semiconductor, so their conductivity not as good as metal. Okay, to increase electrical conductivity of the semiconductor, you can use a doping process, or you can increase the temperature. Okay, so this is a graph electrical conductivity against proton number. Okay, so going down group 14, the electrical conductivity increase. So we have to look at the atomic radius to explain the electrical conductivity. So the atomic radius also increasing because going down group 14, the number of orbitals increases. Okay, so hence screening effect increases. Okay, so when the screening effect increases, the effective nuclear charge will be decreased. Okay, because you learned before, effective nuclear charge is you take the nuclear charge minus the screening effect. So when screening effect is increasing, the resultant effective nuclear charge will decrease. Okay, so the force of attraction between the nucleus and valence electrons becomes weaker. Okay, so the atomic size increases. Okay, so hence when the atomic size increases, valence electron easier to be localized. So metallic character increases. Hence, result as a result, electrical conductivity increases. Okay, so this is a first physical property for group 14. So you only need to we not only focus these two electrical conductivity, and the next one is melting point. Okay, so tin and lead are metals. So they have high electrical conductivity. Okay. Okay, next one we look at melting point. So going down group 14, the melting points, boiling point also increases, decreases. Okay, so you can see the graph decreases. Okay, so decreases. Okay, so for carbon, carbon, silicon, and germanium, they have giant covalent structure. Okay, so they have strong covalent bonds between the atoms. So strong covalence require a lot of energy to break it. So we have high melting and boiling point for these three elements. So you can see here, diamond have giant covalent structure. Okay, or to be more specific, you can say giant covalent molecular structure. So same thing for silicon. Okay, so the atomic size increases from carbon to silicon and to germanium. So the covalent bond getting longer, like, okay, so when the covalent bond getting longer, the electrons further from nucleus, so the covalent bond will become weaker. Okay, from carbon to germanium. Okay, tin and lead are metals, so due to the large atomic size, the metallic bonds are relatively weak. So it has lower boiling point. They have lower melting point and boiling point than the carbon, silicon, and germanium. Okay, lead although has a bigger size than tin, but because the lead has more closely packed, so you pay attention to this. So lead has more closely packed structure. So the lead has higher melting point than the tin. Okay. Okay, so we look at the first question. Student can try to answer the question in the chat box. Okay, so the melting point decreases from carbon to germanium because, okay, so what is the answer? Strength of covalent bond decrease, van der Waals forces decrease, electrical conductivity increase, atomic mass increase. Okay, so the answer very obvious. Okay, any answer from the students? Cikgu Shannon?
No. Proceed. Still no. Oh yeah, A.
Oh, so answer A, very good. So the answer is A. Okay, so because going down the group, the atomic size increase, so the strength of covalent bond decrease. Covalent bond become longer. Okay, next question, question 2, also very easy. Which causes tin and lead to have low melting points among group 14 elements of the periodic table? So we have bigger atomic radii here, lattice structures, weak metallic bonds, inner pair effects. So any answer from the
Not yet. We're still waiting for the answer.
Okay, thank you.
Okay, we got answer now. Zinichai, C, and
C,
also Bon Long Lim, also C.
also C. Okay. So the answer is should be B, huh? Okay. Should be B. Okay. Because thin and lead they have the metallic lattice structures, huh? Metallic lattice structures, and their size very big, huh? So the lattice structures, the size big, the lattice structure not so strong compared to the giant covalent structure for carbon, silicon, and germanium. So you choose a more accurate answer lah. Choose the lattice structures. Okay. So now we proceed to the chemical properties. So chemical properties, we will focus on chemistry of the tetrachloride and oxides of group 14. Okay, so first we look at chemistry of the tetrachlorides of group 14s. Okay, so all the group 14 elements, they can form covalent tetrachloride. So they form covalent tetrachlorides, MCO4, because they have 4 valence electron. Okay, so the atom of the group 14 elements will undergo sp3 hybridization, so that they can share the valence electron with the 4 chlorine atoms. Okay, so the shape of MCl molecules, so they have 4 atoms surrounding the center atom, like, so means they have tetrahedral shape. Tetrahedral shape. Okay, so the group 14 tetrachlorides, they are liquids, liquid at room temperature. So these tetrachlorides are covalent compounds. So they have simple covalent, okay, to be more specific. Simple covalent molecules. So they are discrete molecules, okay, with the formula MCO4. So the molecules are held together by the weak van der Waals forces. So they are volatile liquid. That means they easily vaporize. They have low boiling point. So when the going down group 14, molar mass increase, right? So when the Waals forces also become stronger, so going down group 14, boiling point will increase. Okay. Next we look at thermal stability for tetrachlorides. Thermal stability of the tetrachlorides decreases down the group. Okay, because the covalent bonds become weak, because the atomic size of group 14 atom become bigger, so getting longer and weaker. Okay, so we look at because of thermally stable for the first 3 elements, tetrachloride, carbon tetrachloride, silicon tetrachloride, and germanium tetrachloride, they are thermally stable. Then going down the group, thermal stability decreases. Thin tetrachloride and lead tetrachloride are not stable, so they easily decompose. So they will form more stable MCl2, okay, and chlorine. So you have to know how to write the equation, okay, write balance equation. Don't have to write the physical stats, okay. So it will produce an SnCl2 and Cl2 for thin tetrachloride. For the lead tetrachloride, we have PbCl2 and Cl2. So same. Okay, then we look at hydrolysis. So hydrolysis very important. Okay, hydrolysis of tetrachlorides. Okay, so all the tetrachlorides of group 14 will undergo hydrolysis except the CCl4. So all the other will react. Okay, react with water. So you remember CCl4 does not react with water. So the example, silicon tetrachloride. Okay, silicon tetrachloride can produce white films in the moist air. Moist air has water. So it will hydrolyze by water rapidly. So you must know how to write the equation. Okay, so SiCl4 plus 2 water form the silicon dioxide and hydrogen chloride gas. Okay, the products of the reaction is a white film, has hydrogen chloride fumes, and the white precipitate. So these are the observation. Okay, so the white precipitate is a hydrated silicon dioxide. So you can look at the picture here. So this picture from the YouTube. You can watch this one for the experiment. Okay, so the white film produces hydrogen chloride. This is a white film. You can test the white film with the litmus paper. Moist smooth litmus paper will become red. Okay, then you also can test with the ammonia gas. So the white film ammonium chloride solid form also. So become more white film. Okay, so the ease of hydrolysis decreases. Okay, so ease of hydrolysis decreases going down the group. Okay. Okay, so silicon easier to be hydrolyzed. Okay. Because metallic character increase. Okay. Because it's a metallic character increase, so means more difficult to form the covalent bond. Okay, silicon has empty 3D orbital, so silicon can form covalent bond with the water molecule. Okay, so when they form covalent bond, so means the existed bond is become weaker, so easier to be broken. Okay, for carbon, this is not possible because carbon does not have d orbitals. Okay, so carbon does not have d orbitals. Okay, you don't write carbon does not have empty, because carbon does not have any d orbitals at all, so you don't write empty. Okay, only write empty for the silicon. Okay, so this is a process. So silicon tetrachloride okay, can form covalent bond with the water. Okay, so so the existed bond silicon chlorine bond will be weakened, so easier to break and combine with the hydrogen of the water. So we have 4 hydrogen chloride produced. Okay, then SiO2 form. Okay, remember don't write dots and arrow together. If you already write arrow, cannot write dot. Okay, if you write like this, means you got 4 electrons here. So you just either you write the electrons or you write arrow. Okay, raw arrow or you write electron. So far, any question?
No question.
No question. Okay, so can proceed the next question now. Okay, so I proceed. So question number 3, we have tetrachlorides of group 14 in the periodic table are colorless and volatile liquids. Which statement is true about the first and the last tetrachlorides of group 14? So we have answer here, CCl4 is more stable when heated compared to lead tetrachloride. We also have CCl4 has a lower boiling point compared to PbCl4. CCl4 is a covalent, whereas PbCl4 is an ionic compound. CCl4 and PbCl4 undergo hydrolysis. So which is the answer? Let's try, student. Any question? Any answer from the?
Not yet.
Okay.
Okay, we have yeah, Bun Long Lim,
Okay.
C.
C. Okay. Any other answer?
Only Bun Long Lim.
Okay. So I show the answer. So the correct answer should be A. Huh?
Zin Cincai, B.
I got Xin Cai. Zi Xin is what answer? Xin Cai is what answer?
D.
D. Okay. So the correct answer should be A lah. Okay. So thermal stability decrease down the group. So CCO4 is more stable. Then the second one, low boiling point long because they are all covalent. All the tetrachlorides are covalent. So C also wrong. So when they are all van der Waals forces. Okay, all of them are volatile liquid. So means going down group, molar mass increase. Right? So this one carbon must have CCl4 must have higher low boiling point. Okay, then CC. Okay, this one special case. Going down group should be this one. PbCl4 has higher boiling point because molar mass increase. So PbCl4 should have higher boiling point. Okay, but this one special case. CCl4 will have higher boiling point than PbCl4. I show you the value. So you can see here. CCl4 will have higher boiling point. Okay, than SiCO4. In fact, it also higher than PbCl4. Okay. So this is because carbon CO is more carbon CO is more polar. No, this one carbon CO more polar than SiCO. Okay, carbon CO more polar than SiCO, although not more polar than Pb. But CCl4 has higher boiling point. So this one special case, CCl4. Okay, then the last one, CCl4 cannot undergo hydrolysis. So that's how got student choose D is wrong. Okay, then we look at question 4. Which
Okay,
chloride
teacher
compound?
Vivi Lau. Teacher Vivi
Yeah.
Lau. Now it's time for second passcode, and after that we take a break. Okay, baiklah para
Okay,
pelajar sekalian. Ya, kini tibalah masa untuk cikgu umumkan passcode kredit AYU di pertengahan siaran. Passcode-nya ialah nombor 3 dan nombor 7. Cikgu ulang, nombornya ialah nombor 3 dan nombor 7. Okay, we take a break.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Okey, teruskan Teacher Vivi
Okay, so
Lau.
I continue. So next question, we have question which correct compound would bleach the color of lamp litmus paper at room temperature? So this one just now about the thermal stability lah. Okay, so you have to remember the reaction equation. So here got keywords, bleach. Okay, any answer from the students?
They still thinking.
Still thinking, okay. So you look for the keyword here, got bleach. Okay, then the stability,
Okay, we have answer
Okay.
from Boon Long Lim. C.
Okay. What is the answer?
C.
C.
Chemistry.
Okay. Any other answer?
Zin Z Chincai also C.
C. Okay. So the correct answer should be donkey. PbCO4, because just now you learned that the tin and the Pb not stable, right? Because thermal stability decrease. So PbCO4 will easily recompose. Easily recompose to form the PbCO2 and chlorine. So chlorine gas is bleaching. Okay, will form the HClO, which teacher Kong taught you last time. Okay, so it will bleach make the litmus paper become white color. Okay, so now we proceed to the last part, the chemistry of the oxides of group 14. Okay, so first we have to know the relative stability of positive 2 and positive 4 oxidation state. So going down group 14, okay, so you can see here, the positive 2 oxidation state increases, then the positive 4 oxidation decreases. Okay. Okay, so based on that, the most common oxidation number in group 14 is positive 4. Okay, so we have carbon dioxide, CCl4, SiO2, SiCl4, GeO2 are the examples. Okay, the state with an oxidation number of positive 2 become increasingly stable with increasing atomic number. Means going down group 14, positive 2 oxidation state is become more stable. For example, when the elements are heated with oxygen, they form the oxide CO2 dioxide. Okay, and SNO2. Okay, SiO2 also, GeO2 also. Okay, and but PV we have PBO lah. Okay, because PBO is positive 2 oxidation state. Oxygen always negative 2 lah. So Pb will be positive 2. Okay, so note that the elements have an oxidation number of positive all in all these oxide except the PbO. Okay, so all positive 4, except PbO is positive 2. Okay. So in carbon monoxide, carbon exhibits an oxidation number of positive 2. Okay, carbon monoxide is unstable and is oxidized readily in air to form the carbon dioxide. Okay, so carbon monoxide is a strong reducing agent, or we say reductant in the industry. Okay, example, in the blast furnace, it reduces iron trioxide to iron. Okay, to produce iron, we want to get iron, right? We use the carbon monoxide in the industry. Okay, so carbon monoxide will took the oxygen from the iron trioxide. Okay, then we have lead 4 oxide. So because lead is more stable in positive 2, so it's a powerful oxidizing agent. So it will tends to reduce and form positive 2. Okay, and it also easily decompose on heating to form the more stable lead 2 oxide and oxygen. Okay, and it also can oxidize iodide ion to iodine. So the equation into fast. Okay. So the lead 4 oxide easily recompose on heating and form the lead 2 oxide and oxygen. And then it also can oxidize iodide, ion into iodine. Okay. So it itself will undergo reduction from the lead 2 ion. Okay. So far, any question? Okay. If not,
Not
I
yet.
proceed. Not yet. Okay. So we look at continue. We have tin 2 ions. So tin 2 ions are reducing agent. Okay. Tin 2 ions are oxidized by richromate 6 ions, and the color changes from orange to green because richromate 6 is orange. So it will form chromium ion. Okay, so chromium is green. Okay, so the tin will oxidize into tin 4 ion. Okay. So you can get the equation from the later book. So you write the half equation first. Write the half equation first, then you balance the equation by balance the electron. Okay, so we have two here, two half equation. Tin 2 form tin 4, then the richromate 6 from the chromium. Okay, then you have to explain the inner pair effect. Okay, so inner pair effect is for lead. Okay, because lead has a big atom. Okay, very big atom. So the CS2, the valence electronic configuration for lead, CS2 6p2. Here should not have comma. So I cancel a comma. Okay. So between 6s and 6p orbital, we have big energy difference. Okay. So so this make the 6s electron, which is inner, more closer to the nucleus, difficult to promote to the 6p. Okay. So difficult for the 6s electron to be promoted to the 6p orbitals. So these two electrons, these two s electron will remain as inert pair. Okay, and will not involve in the chemical bonding. Okay. So therefore, the lead tends to form stable compound with the positive 2 oxidation state. So it will explain why the lead has stable positive 2 oxidation state using the inner pair effect. Okay. So the inner pair refer to the two s electrons. Okay, due to the large energy difference between the s and p. Okay. So far, any question? No. Okay. So we look at the
No.
outside character of. Okay. Thank you. We look at so far at outside character of the group 14. Group 14 outside. Okay. So you have to remember this. For the monocyte. Monocyte, the structure change from molecular. So this is simple molecular. Carbon monocyte. Okay. To ionic with covalent character. Okay. So germanium tin, lead. Germanium tin is metalloid, right? Tin, lead is metals. So the non-metal has simple molecular structure. Okay. Thermal stabilities are low. Okay. Okay. For the lead monocyte, the thermal stability is high. Okay. This one is monocyte. Okay. But for the like outside, lead 2, lead 4. Okay. Lead 4 oxide are low thermal stability because more stable as the positive 2. Okay. Then acid base character you also have to remember. So for the monocyte they are neutral. Okay. For the carbon monocyte, silicon monocyte are neutral. Then from the metalloid, metal they are amphoteric. Okay. So remember this. Okay. Okay. For the positive 4 oxidation state, dioxide. So the thermal stability of the positive are all high. Okay. Okay. Means thermal stability is high for this one, carbon to tin. But for the lead 4 oxide, the thermal stability is low. Lead 4 oxide will easily decompose. Okay. Okay. Then we have structure. Carbon dioxide is simple molecular. Okay. They are gas side. Then silicon dioxide, just now you learn, giant covalent molecular structure. So it has high melting point. Okay, germanium 4 oxide and the germanium dioxide and tin dioxide, they have, and also the last one, the lead 4 oxide, they has intermediate between giant and ionic molecules. Okay, intermediate between giant and ionic molecules. Okay, then the acid base character. So carbon dioxide is acidic, okay. Silicon dioxide also acidic. You learn this in the periodicity. Okay, so the non-metal dioxide, they are acidic. Okay, for the metalloid amphoteric. Okay, and the metal oxide also amphoteric. Okay, so this one is amphoteric. This one the move up already. So the lead 4 oxide also amphoteric. This one is amphoteric. Amphoteric. Okay, so we look at. Okay, so the explanation as a general rule, the oxides of non-metals are acidic. The oxides of metalloid are usually amphoteric, and oxides of the most metals are basic, although some are amphoteric. Okay. The group 14 elements form monocytes. So monocyte we have positive 2 oxidation state, and dioxide positive 4. The tendency to form stable dioxide increases down the group. Okay. Positive 4, except the red, that is positive 2. The oxide becomes more basic down the group 14 because of increasing metallic character. Oxide with positive 4 oxidation state are more acidic than oxide with positive 2 oxidation states. Okay. as a result of the group 14 trend from non-metal to metal down the group, you might expect the oxide become less acidic because non-metal acidic, metal basic. So less acidic, more basic as the atomic number increases. Okay, carbon carbon dioxide is an acidic gas, so it dissolves in water to give an acidic solution. Okay, so the equation carbonic acid. So you also can neutralize the base to give carbonate salts. Okay, silicon dioxide also acidic, but it has it's a giant covalent molecular structure, so it has high melting point. So it forms the sodium silicate and water. So this one you have learned in periodicity. So I go fast. Okay, lead 2 oxide is
Teacher Vivi
amphoteric.
Lau.
Yes.
Teacher Vivi Lau.
Yeah.
We have a question from Boon Long Lim.
Yeah.
PbO2 should write as lead 4 oxide or lead dioxide? PbO2. PbO2 should write as lead 4 oxide or lead
Okay.
dioxide?
So write lead PbO2 lead 4 oxide more accurate because
Yeah.
ionic compound. Okay. Dioxide is for covalent, so you write lead 4 oxide. Okay. Lead 4 oxide
Okay, thank you.
here because here is general one. This one we say going down the group. Okay, going down the group. They say dioxide oxide, dioxide. Because generally they say that. Okay. Going down the group. Okay. But for the PB, it's a. You look at the table. I show you the table. So it's a ionic. Okay. Ionic no molecules. So here got mistake. Okay. Ionic compound. Molecule is for the covalent. So it's PbO2 is ionic. Ionic with covalent character. Okay. So Pb lead 4 oxide. So this one is also ionic with covalent character. So lead 2 oxide. Okay. So with covalent character, this one amphoteric. So this one also amphoteric. Okay. Ionic with covalent character. Covalent character. Just now didn't notice a molecule. So it's ionic covalent character. Okay. Ionic with covalent character. So for the ionic compound, you have to use oxidation state. Lead 2 oxide, lead 4 oxide. Okay, I go to the just now what question? Okay, so we look at lead 2 oxide. Okay, so this one the oxidation state must combine together. Okay. Wait first. So oxidation combine together. Okay. So lead 2 oxide PbO is amphoteric. Ionic compound with covalent character, so it can react with both bases and acids. Okay, so this is these are the equation. Okay. So if react with the acid, form the lead 2 chloride. Let's say hydrochloric acid, lead 2 chloride. So alkali, so form the plumbate ion. Okay.
Teacher Vivi Lau,
Yes.
you stop your sharing your.
I stopped sharing. Okay, sorry. Maybe just now I stopped the. Okay, sorry. Okay, so I share again. Okay, just now here. Okay, so let to offset. You have to write the name together, oxidation state. Write together. Okay. So PBO is amphoteric. So ionic compound with covalent character. So they have amphoteric properties. So can react with both bases and acid. So if react with the acid from the lead to, let's say hydrochloric acid from lead to chloride. If sodium hydroxide from the sodium PB bracket OH4. So you have to memorize the formula. Okay. So we call this one tetrahydroxyl pambrate 2. Okay, so I write the name here. So this is tetrahydroxyl. The question seldom ask you to name that. Okay, in case they ask you to name it, tetrahydroxyl pambrate 2. Okay, ion. So the oxidation state write together, no spacing. Okay, then space ion. Okay. So the equation are similar for Germanian, same equation, same pattern for GEO, SNO, and PBO. So PBO is here, okay? Same pattern. Okay, now we look at the question. So which ionic compound is stable due to the inner pair effect? Okay, student can try. Any answer from the student?
Bun long lim B.
Okay, D, huh? Any more
B
answer?
B.
Oh, boy.
Boy.
Okay, any more answer? No more answer.
No.
Okay, so I show the answer. So should be C, because B the here is positive for oxidation state. Positive for means the PB has to give out the S electron also, but PB has inner pair. Inner pair, the 6s electron is inert. 6s electron is inert. So you have to choose this one, PbCl2. This one, the lead oxidation state is 2, positive 2. Okay. So you have to choose a stable one. Okay. Okay, next question. Which is a common property for germanium and lead compounds? Okay, any answer from the student?
Not yet.
Okay, any answer from the student? So you can see here common properties. Okay, so we check. So just now inner pair effect is specific for which one? Okay, then the tetra corrects. Okay, both are thermally stable, is it correct? Okay. Dioxides both amphoteric, monoxides both basic. Okay. So any answer from the student?
They still thinking.
Still thinking, right?
C. Chemistry.
Oh, got answer C. Okay, very good. So
It's
the answer is C.
and bone long limb. C.
Very good. Okay. So the dioxide of both are amphoteric. Okay. So you have to memorize the table just now. Okay. Then we look at next question. A thermally stable liquid MCl4 reacts with water to form a solution of low pH value. Which statement about M or its oxide is true? So you see here, mention thermally stable. Okay, then reacts with water form pH, low pH value. So the answer we have, is it MO is an acidic oxide? Okay. So you must determine the M first. Okay, from here, thermally stable, then reacts with water. Okay, then you decide what is M, then you look at the answer. The monoxide, is it acidic? Okay. Any answer from the students?
Not yet. We have 2 minutes more to go.
Oh, 2 minutes. Okay. So I show you the answer. So the answer should be B. Okay. So you can see here I show. So because it's thermally stable, so should be SiCl4. Okay. Cannot be C carbon because going down the group, the thermal stability decrease. So thermally stable one Si lah. CCl4 more stable, but CCl4 cannot react with water. So you choose Si. Okay. So SiCl4 reacts with water form the hydrogen chloride. Okay. Then okay. So you know it's Si already. So SiO is neutral. SiO is neutral. Then SiO is SiO2. SiO2 is giant covalent, but now it's SiO. SiO is simple molecule correct. Okay, so this one correct. Okay, SiO2 is a reducing agent wrong. Okay, because SiO2 is already giant covalent, cannot oxidize anymore. Okay, then Si is a good electrical conductor. Si is semiconductor, so we don't say good. Okay, it's a semiconductor. Okay, then we look at question 8. You still have time? Oh, okay, last question. Time's up already. Elements of group 14 in the periodic table forms oxide with positive 2 and positive 4 oxidation state. Which statement is true about the oxides? So I try this one, last one. So it's a carbon monoxide is a reducing agent. Okay, any answer from the student?
Not yet.
So for group 14, you have to memorize. Okay, any answer?
I think you have to give the answer.
Okay, time's sorry. So I give the answer. So remember carbon more stable and positive for oxidation state. So A is the answer. So carbon monoxide easily oxidized. So it's a good
Yeah,
reducing
Zin
agent.
Cincai answer A.
Okay, very good.
Zin
Okay,
Cincai.
okay,
And
so
also also.
also A. Okay, very good. Okay. So I end for today's lesson. Okay, thank you very much for joining the class.
Okey, Alhamdulillah sudah selesai kelas kita pada petang ini. Tahniah diucapkan kepada semua yang setia bersama kelas pada petang ini dari awal sehingga ke saat ini. Anda memang pelajar yang hebat. Kini tiba pula untuk cikgu umumkan paskut kredit AYU yang terakhir. Nombornya ialah 2. Diulang, paskut yang terakhir untuk kredit AYU ialah nombor 2. Jadi sebelum kita tamatkan sesi siaran langsung hari ini, mohon tutup ruangan chat dan klik butang subscribe dan aktifkan ikon loceng supaya kamu tidak terlepas sesi kelas yang seterusnya. Sekiranya sesi ini bermanfaat, silalah klik butang like dan share kepada rakan-rakan media sosial kamu untuk sebarkan ilmu dan beroleh kebaikan atas perkongsian ini. Alright, link sijil telah pun diberikan, ya, saya lihat dah ada tu di ruang komen, dan username untuk teacher Vivi Lau pun telah pun diberikan. Sila berperhatian, link sijil ini akan tamat tempohnya setengah jam sebelum berakhir. Sekali lagi diucapkan terima kasih kepada teacher Vivi Lau atas penyediaan pelajaran pada hari ini. Terima kasih juga kepada teacher Tang, teacher Kong yang sudi bersama-sama kita pada hari ini. Akhir kata, terimalah serangkap pantun. Tak pernah berpantun lagi. Kali ini kita berpantun. Di atas dahan burung tempua melihat rusa tepi pergi. Salam perpisahan untuk semua. Di lain masa bersua lagi. Sekian. Wassalamualaikum warahmatullahi wabarakatuh. Jumpa lagi di minggu hadapan. Bye-bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.